Hello and welcome to the day 11 of the Advent of Code. Today's task is cosmic expansion. So let's read it. You continue following signs for hot springs and eventually come across an observatory. An elf turns out to be a researcher studying cosmic expansion using the giant telescope here. He does not know anything about the missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest the next closest area likely to have people. Blah, blah, blah. The researcher has collected a bunch of data and compiled the data into a single giant image, a puzzle input. The image includes empty space and galaxies, denoted by a hash. For example, let's copy this example. Now, the researcher is trying to figure out the sum of the length of the shortest path between every pair of galaxies. However, there is a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all actually be twice as big. In the above example, 3 columns and 2 rows contain no galaxies. This column contains a galaxy, this one contains, this one doesn't, the third one. Then this contains, this doesn't. This one doesn't, this contains, and every other column contains it. Yeah, so this row does not contain it, and this row doesn't contain any galaxies. Okay, so yeah, and okay, that's why the following rows get twice as big. The result of the cosmic expansion therefore looks like this. Okay. Equipped with this expanding universe, the shortest path between every pair of galaxies can be found. In these 9 galaxies there are 36 pairs. N multiplied by 8 divided by 4. So that is 9 by 4, which means 36 pairs. Only count each pair once. Okay. The other direction doesn't count. Find any shortest path between 2 galaxies using only steps that move up, down, left, right exactly once, one dot or a galaxy at a time. Okay. This path has length 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because it takes a minimum of 9 steps to get from galaxy 5 to galaxy 9. Can this be calculated as the sum of the differences in the coordinates? So, for example, the difference in the vertical coordinate is 1, 2, 3, 4, 5, and the difference in these coordinates is 1, 2, 3, 4. Okay, I will need to verify this, but that looks reasonable. And I also do not need to search anything, it's just a straight path. I just need to expand the universe first. Okay. Okay. Between galaxy 1 and galaxy 7. Wow, that's a lot of steps. 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, that's 15. Yeah. Okay, the sum of the shortest path is 374, and I need to get the sum. Let's look at the puzzle input. Okay, that's pretty big, but not that huge. Let's save it into 11. Okay, let's start. Stick in it. Stick on. So it works. Now let's solve it. So the usual boilerplate. Let's get the input. And let's print the solution. Now let's print that in. So what would be the immediate representation? Image. Not the best name. It's not a sky map exactly. I like it. So it's something. Parsing produces a sky map. Parse input, undefined, solve, takes the sky map, and it produces an integer, which is the sum of all these things. Sky map, undefined. Okay, now let's start with the parsing, and let's think how to represent this structure. So what will be the solution? First of all, expand the universe. The first step is expand the universe. Find the empty rows and columns. Expand. The second part. For all pairs of galaxies. Get the distance. Sum it up. Okay. So do I need any additional information to bring between the first step and the second one? No, I think not. So I can actually say that the solution consists of expand, and then all distances and then sum them. Now expand takes the sky map, but well, why do I do that? I haven't even parsed it yet. Okay, let's start here. So for all these steps, if I use just a map, I can find the empty rows and columns. I can change the keys for all pairs of galaxies, get the distance, and sum it up. So if I use a map which is in containers, build depends on containers again. Let's reload this. Let's bring in qualified data map, and let's say that the sky map is a map from type, again, point is from is a pair of integers, represents the coordinate, and the sky map, this could basically be a set. Do I have to carry any information about each galaxy? Oh, nice. I can actually do a set of points. Okay, now let's pause it. So what is the example file? Okay, yeah, let's just do the usual. Dip with lines of input, and if I zip it with indexes from 0 to as much as needed, as many as needed, and then I get the coordinate I and a line. Then I can zip the line with from 0 to as long as needed, with again a callback which gets coordinate j and a character. Okay, that sounds good. And this produces if character is equal to a galaxy, then just ij, else nothing. Should I do that here? Oh, yeah, that is okay. Parse character. Okay, parse character, parse line. Again, let's take it here, and let's say that dip with parse line. Oh yes, parse character must take I now, and it must take it here as well. Okay. Here, let's move them to the arguments as well. Okay, nothing. Why not? Why not what? Okay. Now, when I have the list of just something or nothing, I can do cat maybes. which comes from data maybe, get maybes, thanks. And now I just have the list that I can put into a map from list. What's wrong with it? No. Oh, okay, it must be a set. At line 11. Get maybes. Okay. Deep width. Okay. And what produces a parse line? Maybe a pair. Okay. What's one now? Oh yeah, the usual. I have to concat them. Yep. So let's try that. And are the galaxies correct? So the first one is at 0, 0, 1 to 3. The second was in 1, 0, 1, 2, 3, 4, 5, 6, 7. Next one is at 2.0. The next one is at 4.6. The next one is at 1.5, and there are 2 galaxies on the 9th line. Good. Now the parsing is done. Now let's solve it. Let's say, how do we expand it? Sky map into another sky map. Expand. Sky map. Undefined. And let's say that all distances takes a sky map and produces a list of ints. Okay, that sounds good enough. Expand sky map. Okay, let's keep it undefined. So first of all, we have to find the max sky. Oh, finally a nice name for a variable. Yeah, sky. Now let's take it as to. Can I find the minimum and the maximum? Max view. What is this? Okay. Okay, now let's find our lines, and I first do that here. So I ask okay, and can I unzip it? Yes, perfect. And then I just have to find the maximum and the minimum of each of these. So i's j's is equal to unzip as to list sky, and for each of them I have to find the minimum and the maximum, and that can be I's, let's just sort I's and J's. Let's just sort J's. Then max imax and yeah, imin and imax are equal to really have to sort that. Should this really matter? Is there an efficient way to get a maximum and minimum at the same time? Should I just write it like this and be done? Maximum of j's. And the same goes for j's. Yeah. Now that I know imin and imax, I can have a range which looks like this. And given this range, I can test if there are any keys with these eyes. Oh, yeah, let's invent some crazy list comprehension. Okay, let's just do it in any way possible. Yeah, so sky, and this produces let. Actually, it could be written in this way, that I1, I0, I1 i's, j's in max minimum of i's, maximum of i's, minimum of j's, maximum of j's. Yeah. Okay, I think that's good enough. Now, what do I have to do? Given indexes over I from 0 to 9, I have to produce what? I have to produce I, given that S member okay. So so again, I want to count all of the rows 0 to 9 such that this expression is empty, and this expression is I take any ij or even j, where j go from 0 to 8, given that that ij is a member of the sky map. That finds me two lines, line 0, 1, 2, 3, 4, 5, 6, 7. And that actually looks good. And if I change that in the another direction, I collect all j's, such as in all rows, I find 0, 1, 2, which looks sensible. Cursor column. And I find 2, 3, 4, 5, which also doesn't contain any galaxies. And I find 8, which is 6, 7, 8, which is this one. Okay, that looks correct. Let's move that here. And let's say that empty rows are equal to I, where I is taken from imin to imax, such that this expression is null. And this expression takes j, where j is taken from 0, not from 0, but from j min to j max. And this condition must hold. And empty columns are all j's, where j's are taken from j min to j max, where this condition holds. Null, where this comprehension is null, and the comprehension is we take all of the rows and I mean to imax, and such as ij is a member of the sky map. Okay, now that we know the empty rows and empty no, these ones are empty columns, and this one is empty rows. Okay. Now, what do I have to do? I have to change the map. In which way? The set. In which way? And now it gets interesting. So how do I add another row in that? So if I take set to send in list, it's easy to iterate over it. Okay, so could I do a binary search to quickly find the position? So basically, if I know how many empty rows are from the start in here, let's keep it for now. So if I know that, for example, so I need to count the number of empty rows whose coordinate is less than the given coordinate. So this one and no others. For each empty row, I have to increase the index by 1. So I have to add a new empty row. And I have to also count all of the columns to the left, which are empty. And for them, I also have to increase that by 1. Okay. Yeah. How can I do that quickly? Is there anything like set, find, index? So what does it do exactly? So given I have my rows, and if I actually, is this a regular find index? I think it's better to use a set in this case. What I could even do, I can make this a set as well, and that will give me a logarithmic time search over them. Okay. Now, these are sets of ints, and I can actually apply this command to quickly find a value. But what happens if I try to find a value like 3 in it? It produces an index 0, but what if I ask for a value 4? And now it blows up. The element is not in the set. Can I actually find anything that is smaller? Lookup index. Yes, that's ideal. Now I can just ask, please look up index 3, 4. Okay, that does not tell me. That doesn't actually tell me what I want. Okay, so what I can do first, I can look up less or equal. In what? In the I'm look for 3 in the set made from empty rows. Okay. If I look at 4, I get just 3, and that actually tells me so for each okay, and when I have sets, can I map them monotonic? What's that? Interesting. What does map monotonic set monotonic do? Map monotonic. Not quite sure why this matters. Oh, it's a little bit faster than this. Oh, okay. Yeah, well, in my case, it is a little bit monotonic, but interesting. Okay, so what do I call that? Offset. Uh, offset. So, given a coordinate I, j, I want to know how should I offset this ij, and this should be basically b. Let dx is, or let's call it, well, let's just do it like this. I have a couple of coordinates, and then I return I plus something, j plus something. Now, I need to figure out by how many rows I have to offset the given I, and that depends on, and that actually depends on the I, and it is calculated as I have to find find index of maybe. So I will have when I try to do s lookup less than equal of I in empty rows, for example 3, I will be getting a maybe. In case of nothing, there are no rows that are that are less than this one. In that case, I just offset by 0. In case a smaller empty row was found, I get its index. And now I have to figure out how many rows are there. So basically find index for I in rows. And yeah, let's say that rows, how do I take the previous value? How did I construct it? Okay, and let's say that this is a set from list. Yep, and now let's repeat that. So, for example, for 3, I don't have to shift it because it's 0. For 4, is it even possible to have something on the row 0, 1, 2? Well, I'm talking about rows, right? So this is 0, 1, 2, 3, 4. And actually for 4, it must be shifted. Okay. Why do I not get the shift? Oh, because when I find the index 0, it means that there is at least one row to shift with. Okay, and in case of 3, case of 2, it does not shift by anything. The case of 3 doesn't matter because 0, 1, 2, 3, it's an empty row anyway, so it doesn't make any sense to do that. And the second row is 7. And the 8th one must be shifted by, well, just 7, right? What's wrong with it? Find index of 7 in the sky? Not in the sky, but in arrows. And that should produce 2. Oh, right, yeah. 7, 6, yes. I think that's the correct behavior. 0, 1, 2, 3. After that, it shifts by 1, 4, 5, 6, 7, 8 is shifted by 2. Yeah, so that looks correct. Let's just put it in here. Yeah. So let's create a little helper that num empty, and it takes some kind of index, and it's equal to maybe 0, and if it's some index, then s find index I. Oh yes, and it also should have empties. Whatever, empties. Lookup le index in empties. Avoid lambda using infix. Yeah, I can do that. So this is identical to what I had here before. Okay, now num empties in the set of empty rows, and here it's num of empty in the set of empty columns, and it must be also applied to j, and this must be applied to I. Yeah. Let's try that. So I want to expand the sky, and that happens with I map a set of sky with given a point ij, I offset it. Okay, let's just say that, let's just replace why does it not work? Oh, okay, some parenthesis was missing. So yeah, let's just map it with the offset. How do you get the results back? Should I try to print it right now? How much time will it take to try to print the sky map? Okay, let's just look at the numbers and try to decipher them by hand. So let's reload, let's reparse, and let's say that we want to let's look at the sky, and let's say that we want to expand the sky. So the closest ones are the same. The next one is shifted by, this was this one, and it gets shifted to the right by 1 position, because this is an empty column and this is an empty column. Okay. Wait, there are 2 empty columns in here. Why is it shifted just by 1 position? Yeah, this column is empty and this one is empty, but it gets shifted by only one position. Oh, something is wrong here. Oh, right. Yeah, I cannot escape this. I need 1 plus find index I in an empties. Yeah. What's on here? Oh, it's name shading. Yeah. What do I do about this? Let's call it I prime. Let's reload. Let's reparse. Let's expand. Yeah, now it's shifted by 2 positions. Next one. Yeah, and let's compare it to the sky. 2, 0. It is not shifted anywhere. That's good. What was 4, 6? It must be shifted by 1, 2. So it must be shifted to 8 to the right. And does it change its position? Yeah, it changes because there was an empty row here. Okay, that's good. Is that good enough? So, for example, if I take this one, what was that before? It was 8, 7, right? And it becomes 10, 9. Wait. 1, 2, and here. Okay. It can be only shifted by 2 to the right. Yeah, that's correct. Okay, yep. So expansion works. Now I have to find all distances. So given a sky, I have to find all of the pairs in it. Let's look at the set again. So what's Cartesian products in here? It takes the set and produces a set of tuples. So if I take a look at Cartesian product sky with the sky, oh yeah, let's reparse the sky. So if I look at the Cartesian product, okay, I should avoid these pairs. That's one thing. Okay, I also should avoid back pairs. Okay. Or actually, can I just fold? What does fold do by default in this case? Is it equal to foldle? No, it's equal to folder. Okay. That's good enough. Set, can I discard or delete anything from a set? I can. And that actually gives me the solution. I can take a set of all galaxies, maybe an expanded one, and then I can say fold R. What is it type? Some callback. The initial state is well, interesting. What do I want to produce? Oh, maybe list comprehension will help me again. So Oh, again, it must be a list comprehension over the coordinates. Okay, I think this is not a problem. Oh, this is actually a useful helper. Yeah, maybe it's in here already, indexes, ranges. Max view, min view. Yeah, let's just say that I want to have a helper that takes me the range of a sky map. And this is what it produces a pair of int range and range over range rows of a sky is equal to oh, okay. Actually, it might make sense to just keep it in one operation, range, and this will be actually a range over rows, and this will be a range over columns. And then I can say that where I take sky, I unzip that, and that gives me rows and columns. Then I just say that this is the first one is minimum over rows and maximum over rows, and this is minimum over columns and maximum over columns. And I'm very hopeful that GHC can do some magic to actually write it into something efficient, because but in the worst case it's just two passes over it. Okay, what is failing now? Yeah, I agree. Now I don't have imin imax, and I don't have jmin jmax, and that comes from range of the sky. Let's reload. It type checks now. Let's reparse and let's expand. Yeah. Does this look reasonable? Zero. Oh yeah. Yeah. It should shift by one to the right. This one does not shift. Okay, yeah. That still looks reasonable. Okay. Now, when I want to calculate all distances, what do I have to do? Do I just try to probe all of the pairs linearly? So yeah, my assumption was that I would get the range, and then I would just try to oh, okay, yeah, that's a bad idea. Okay, yeah, I should fall back to the plan one. So I can produce, so given a sky, I can produce a list. I can iterate over it, and then for each of these, oh, that's why I need fold. kind of weird. It's a bit of an anti-fold. It just tries to drain the elements from its state. Is there anything like this here? Power set, show tree, size, lookup min. Filter, lm, stop while antitone. What's this one? Oh, but it does not have the state. Okay. So it looks like I just have to write this myself. So let's say that it's go sky, where go takes a set, and what it does next. If the set is empty, that's the constructor of an empty set, and null checks if it's empty. Yeah, because Haskell. Now I have a helper that what does S.drop do? Oh, okay. Is there anything like min view? Okay, that sounds like I want, what I want. Oh, that's basically unfolder, the good old unfolder. Qualified data list as L, and this is the good old friend. So now, what does it do? It takes a callback, it takes a state, which is the sky, and given a sky, it tries to do the following. First of all, it tries to do a min view of the given state. Then, if it gets a just a pair of a minimal point in it and the rest, I can do the following. Map yeah, there is a module in Haskell where you can map over the second element of a tuple, but it's not really but yeah, I just don't want to bother with it right now. So, given a state, I get an element in it, which is a point. Now, okay, as min. Oh, okay, and that must be a little bit different. Set, and this must be a new set, a smaller set. So we return the smaller set, and what we produce? We iterate over the list of the remaining points and map it with the distance between this point and that point, and that is basically I1 J1 and what I produce is the absolute value of let's call this I0, I0, I1, and here I1 minus I0, and the absolute value is I J1 minus J0. If they are equal, the distance is 1. Okay. What's 1 here? Variable not in scope, J0. Yeah, because it must be defined here. Okay, now I have an inscrutable type error. Good. So now I know that this is an unfolder of a sky, and this must be concatenated back at the end, because each of the steps of the unfolder produces a list of distances. So now this will be our go iteration routine, and what is it like? I take a set and I convert it to the list. Wait, no. I do min view, and I map the result with. So if I get a point, which will be I0, J0 anyway, then I have to map them as follow as this. I have to map S to list S with something that discharges this into a point, and now I can produce the distance, which will be okay, what's the type of apps? Yeah, it's okay, and yeah, let's say that this will be apps I0 I1 minus I0 plus apps of J1 minus J0. Yeah, and here it is. Yeah, that should be it. Let's bring in the list module. Let's go back, let's reload, and it blows up again. Why? Could not match the expected type in the line 35. Right. Wow, that's quite hard to read. So let's make it slightly more readable. Do I still need the S? No, I don't think so. So wow. Let's just rewrite it like this because it's just unreadable. So here distance, and let's say that distances are equal to this in distances, and now I still cannot match the types. Why? Interesting. Maybe int a list of ints and a sky map. Now it cannot be matched. S min view S. What's wrong with it? But that sounds reasonable. That returns a maybe. Maybe can be mapped. And min view actually produces this type. It can be destructured. If it can be, then let's make this parentheses in distances and a new set. Oh, couldn't match. The second argument of dollar type map. Oh, well, it's fmap, right? Okay, let's try that. Let's reparse and let's find all distances. And that is spectacularly unhelpful. I don't have any idea what distances I look at. Okay, sum. Let's just hope that it will sum up to what? 374. And it doesn't. Perfect. All distances. Let's just try some obvious steps from list. So what happens if I ask the distances between the points which are 0, 0, 0, 0? I get nothing? Yes, because you don't count that here. Okay, 2, 3, and what if I say now 5? Wow, that's very, very wrong. Oh no, it actually isn't. So 5, 0. But it is 8. Okay, something is wrong here. If I ask the distances like this, it still looks reasonable. Wow. What's wrong? I just have to expand it, so it's correct. I just have to expand all of this. Expand sky. And if I take the sum, I get the right answer. Good. Okay, now let's do some testing. Main example txt 374 input txt. That's a pretty big number. Let's hope it's correct. And it is. Now let's continue. The galaxies are much older. than the researcher initially estimated. Now, instead of the expansion you did before, make each empty row or column 1,000,000 times larger. That is, each empty row should be replaced with 1,000,000 empty rows, and each empty column should be replaced with 1,000,000 empty columns. Okay, I think that my suffering was not wasted in this case. And where is my expand? And this must be multiplied by million. Okay, what are the tests? It's merely 10 times larger. The sum of the shortest pair. Let's reload and let's ask, what would be the output in the example? Oh, that's not good. That's not good. Well, it's almost there. What's wrong with it? If they were 100 times larger. It's almost good. What's wrong? Now, let's think. So, previously each column was expanding into 2 columns. Now they can expand into any amount of... Wait, what happens if I say 99? 140, and what happens if I say 9? I get the right answer, but why? Why? What happened? Do I really want to know? It's 1,000,000 minus 1 multiplied by this. I reload, I get the example txt. Yeah, do they say it? Okay. Input txt. And I get this huge number, and I post it here. And that's the right answer.